Hello everyone, and welcome back to another video. So, Cheap Ass Chips round 1 is over, and I didn't place that well, mostly because my card is not that great, specifically the core. But yeah, I still wanna make a final overview of my card, all the mods that I've done, because I think it would be interesting. I think people would wonder what I did. And this is a reshoot of a video that I referenced in the bench session video. Like, there's a bunch of points where I say, as I said previously, and then there's just no video where I said that. It's this video, I'm reshooting it because I didn't like the previous take. So, yeah. So we're gonna go over the GTX, why am I saying GTX? We're going over the HD6850 CMD Edition, all of its mods, all the mods that I maybe could have done, what it clocks like, and my thoughts about the card. So, let's get right into it with the mods. So, first off, we have this big thing here. This is for volt modding the core, memory, and VDDCI. So, this is not using potentiometers, which is the mainstream way of volt modding things, because I use my Elmer EBC for this, which is essentially the same thing. It's just that instead of a potentiometer, you put in a DAC on board of the EBC, which effectively causes the same thing as turning a potentiometer, and that allows me to volt mod the card. Now, I prefer the EBC volt modding over potentiometers because first off, it's less hassle, and second off, it is very consistent because the EBC can set very precise amounts of current that it will add or draw away from the feedback pin, which corresponds to like a very precise resistance that you would set on a potentiometer, except that on a potentiometer you can't set an absolutely precise resistance, you just like turn it until you get like about the voltage that you want. Then also on the EBC, because there are sense pins, I can actually use the EBC as a triple channel multimeter, where I can just very nicely with a graph monitor the voltage that I'm getting from the core, memory, and VDDCI. So I just really like it for that as well. That's what I use for like the voltage graphs you can see in all my session videos. And that's why I prefer the EBC volt modding over potentiometers, and that's what this giant thing is. So we have a white wire, that's ground. We have two blue wires that go to the core PWM controller, one of them to the feedback pin, the other one to the output. Then we have green, which is the same for memory, and red for VDDCI. And then that all just like goes into this terminal, and then this plugs into the EBC. Then, next thing on the front, I de-shimmed the card. Now there used to be a thin metal shim around the core here. I removed that because like the metal shim is meant to protect the corners of the die from chipping if you like put your cooler on slightly on an angle. But the shim can also cause contact issues if you use a heatsink that has a cold plate larger than the inner open section inside of the shim, which is the case for my phase change unit. So I removed the shim so that it would just like only rest on the core and not maybe on the shim, because sometimes these shims are slightly taller than the core itself, and then you have pretty bad contact on your core. So I removed the shim, and well, core contact is like the best it can be now without lapping the core. Then the last mod, no actually not the last mod, but one of the last mods visible on the front is our yellow wire right here. So this also comes from the vCore PWM controller, and this is an OCP removal and switching frequency set mod at the same time because of how the NCP 53950 works. So, if we turn the card over to the back, where you can see all the beautiful capacitor mods I've done, you can see this horrible mess of resistors. Now this is a resistance of 22 kilo ohms in series, that just goes to ground. And it is there because on the front of the card, this yellow wire goes to a pin on the controller called iLim. Now iLim has a resistance to ground, and it has a resistance to another pin called ROSC. And it just so happens that the resistance between ROSC and iLim sets the overcurrent protection trip point, but the resistance from ROSC to ilim plus the resistance from ilim to ground sets the switching frequency of the VRM. So, if we want to remove our OCP, we have to short ilim and ROSC together. That sets the trip point the highest it goes. But because the switching frequency is that resistance that we just shorted plus whatever is going to ground, it's gonna be different now because we just removed part of that total resistance. And in fact, if I hadn't done anything, the VRM would try to run at about 1 MHz switching frequency, which I can guarantee you does not work. So, I had to fix the total resistance to preserve our switching frequency. And yeah, because we need to short the resistance between the two pins, I moved the entire 22 kilo ohms, that's the stock resistance, between ilim and ground, because that way we still have the same total resistance from ROSC to ground, which means the same switching frequency, but we don't have an OCP anymore. So that's why those resistors exist on the back, because I really didn't feel like soldering anything on the small pads near the controller. And yeah, so coming to this also, I did try 12 kilo ohms first. That would translate to about 600 kilohertz of switching frequency, which I thought is like a level that, you know, should run, should be fine, should help with transient response, and it did. Transient response was slightly better with 600 kilohertz. The thing is, the card didn't work with 600 kilohertz. Like, it would run, seemingly fine, but then you would just run into all kinds of weird issues, like crashing, artifacting, the card not scaling like it should, just driver issues as well, like all kinds of weird stuff, and I almost I almost lost it with this card. When I had the thought of, all this started when I set 600 kilohertz, so I added another 10 kilo ohms to set it back to the 22 kilo ohms stock resistance, which brings it back to 350 kilohertz, and all the issues went away. So 600 kilohertz was apparently still too much for this card. And yeah, I've just put it back to 350, because if 600 doesn't work, then if you want to increase it still but have a good safety margin, you're gonna do like 450. And that over 350, in my opinion, is just not worth it, so didn't do it. Then, I think we can just stay right on the back. We also have this resistor. Now that's another 10 kilo ohm resistor, and this is the PCI Express 2.0 speed mod. Because depending on your platform, this card will only be working at PCI Express 1.1 speeds. Of course, we don't want that, we want the full 2.0 speeds. And the way we can force enable that is this little pull-up resistor right here. Now, if you want a detailed description of how this mod works, go to the HWBot Discord, into the Radeon GPU channel, and look at the pinned messages, because I don't want to spend the time to fully explain this one. But basically what it does is, near the Crossfire connector on most cards there is an exposed GPIO pin, and that GPIO pin, if we pull it high to 3.3 volts through a 10 kilo ohm resistor, it forces the I/O section of the card into 2.0 speeds. And it just so happens that next to the exposed pin, there also happens to be a 3.3 volt pad on most cards. It's not on all of the cards, but on most cards like mine. So we literally just have to pull a 10 kilo ohm resistor between those two pads, and there we go, 2.0 speeds. And yeah, if you want more information, just go on the HWBot Discord and about that. Then, well, there are a lot of capacitors. So there's 12 volt input filtering caps here. These are also input. These three are on VDDCI. This is core, these three are core, and then all of this is memory. Now, the cap mods didn't really do that much, sadly. Electrically they helped. The transient response on both core and memory got a lot better. On VDDCI didn't really change because there basically were no transients on that rail. Like, the VDDCI is a very just smooth rail on this card. It doesn't really spike. But memory and core got measurably better on the oscilloscope. It's just that the card didn't really care about that because, well, the memory chips are not actually the limiting factor on this card. it's the memory controller. And it just so happens that the core I have, which includes the memory controller, just doesn't scale with voltage that well. Like, it scales a little bit, but far less so than most other cards, and that's the main reason why it didn't do that well. And yeah. Then I also have like right here and right there I have an oscilloscope hookup. I redid these at some point. They also used to be one for VDDCI, but I redid them, so they're slightly better. But yeah, that's my oscilloscope hookups. And then we can go back to the front of the card, where I can now address all of the blue goop that's on the card, like on the front here and then on the back here. So this is kneaded eraser, and this is used as insulation to protect the card from condensation while I'm benching at sub-zero, because of course when there's things below zero you're gonna have ice and water, and that stuff usually doesn't mix with electronics that are currently running, and so there's insulation on the card so that it doesn't, you know, have issues, because it did have issues before it had this insulation. And that's all the hardware mods. Yeah, that is all the hardware mods. Now, I was planning to e-power this card. As you can see, the card is not e-powered. So, yeah, the reason why I didn't e-power this is a combination of I just kind of ran out of time, and also I don't think the card would actually, like, improve. Because, like, after all of these mods, the card really didn't get any better. Like, it's... Like, I ran the card when I got it completely unmodified. The only thing I had was like this. Like, I mean, I guess it was modified. I had voltage control on it, but like none of the cap mods and stuff like that was on the card. Like, the only mod I did was like I can increase V-core, and I ran it like that when I got it. And the Firestrike score I got then and the Firestrike score I ended up subbing to HW board were like 50 points apart. So all of these mods basically didn't do anything, which is a bit disappointing. Like, yeah, I just got an unlucky card, because it's not like this architecture doesn't scale, it does scale a lot. There are a lot of people, like the people that have better scores than me, they have cards that absolutely scale like crazy. Mine doesn't. It's pretty good at ambient, actually. Like, my card with the stock heatsink and water cooling, actually pretty actually pretty competitive, but because cheap-as isn't sectioned into different cooling stages, that doesn't really matter, because there are people running dry ice and liquid nitrogen, and you know, on my phase change, this is still better than it is on ambient. It's just that it's no longer competitive compared to other cards running the same sort of cooling. So it kind of sucks. And the main reason is the core. The core on this is not good. Yeah, it doesn't scale with voltage. It doesn't scale with temperature as much as the other cards. Like, there are people running more than 1300 on the core. I, at pretty similar temperatures, ran mid 1100s. Like, yeah, and I can just not make up that amount of core clock disadvantage, even though my memory is pretty good. Like, memory clock on this card, pretty good. The memory controller in the core, because the memory chips are not actually the limiting factor. The chips are actually rated for speeds much higher than what you can even achieve with overclocking. So the memory controller in the core was decent, I guess, but the core itself, just absolute trash. And yeah, like, it didn't like more voltage, it didn't like capacitors, temperature, like sub-zero, it slightly helped the core clocks, but like way less than you would expect. So the core on this is it's just bad. And yeah, that's like the main disappointment with this card. I still had fun modding and benching it. It's just that, yeah, the core on this being bad is just, yeah, it really messed me up. So yeah, that's my excuse for why my placement was bad. I should have just bought a second card, honestly, but I didn't. I only have this one, and it happens to be bad. So yeah, I mean, overall, it was still fun. Like, it's not about winning for me, it's about, like, you know, going through the process of modding your card, like, trying to make it better. And I mean, electrically, measured with the oscilloscope, it did get a lot better. It's just that the core didn't care. Like, the actual core clocks didn't change. So yeah. And I guess that's all I want to say about this. So this is gonna go, I don't know. I'm probably gonna keep it in the state it is. Just like, I have enough capacitors. Cause I just like to keep it around as like a, I don't know, collector's item. It's just like, yeah, this ran in a competition. It didn't do that great. Well, I mean, still top 10, but there were only like 30 people competing, so it's not that impressive. Yeah. But I'm looking forward to the next cheap-as that's gonna happen. People have been throwing around to do it on a CPU this time, not a graphics card, which I would support. I really want to get into like CPU stuff. I've done enough graphics cards. It's been over 4 years now that I've been overclocking graphics cards for fun. And I think it's about time I get into some CPU things. Like, I have some LGA 775 stuff, but none of it is like good. Also, LGA 775 mostly just like CPU binning. And I have like one example of every CPU I have. So yeah, but like other CPU things, like maybe an AMD platform, maybe something slightly newer, Intel. I don't know. I wanna get into like CPU things and like DDR3. I heard DDR2 is a nightmare, so maybe not that, but DDR3, something I would want to do more with. So yeah, if the next cheap-as is gonna be a CPU comp, I would give my approval for that. Provided, of course, that the platform is, you know, cheap enough to get. But I mean, it's cheap-as chips, it's going to be. And with that, I think the video really is long enough now. Hey, it's still below 20 minutes, we did it fine this time. So, yeah. Actually, I don't need to feel bad about rambling. Anyway, thank you for watching, and until next time, goodbye.